Assalamualaikum warahmatullahi wabarakatuh. My name is FARAH binti Muhammad RIDZWAN and my matrix number is 12111109. So actually I will introduce a little bit about the recycling bin. The earliest recorded use of receptacles resembling recycle bin was in Paris in 1818 by Eugene Renoble. There is three types of recycling bin, which is biodegradable waste, paper include, glass and crockery. There is already some of the country that strictly using the regulations of recycling. We have, for example, in South Korea. Next, I will list some of the problems that we see and help us providing this idea of a smart recycling bin. So the first one is lack of awareness about the benefit of recycling. The second one is insufficient amount of recycling bins. The third one is lack of understanding about the composition of the waste. And the fourth one is lack of motivation from the authorities. And the last one is the lack of motivation to distinguish the waste.
Summary of information gathering and analysis. The text discusses the significance of using recycling bins for waste disposal and identify various reasons for the lack of recycling, such as awareness, accessibility, motivation, and inadequate regulations. It suggests user requirement for an effective recycling system, emphasizing clear labeling, equal accessibility, gamified incentives, smart infrastructure, community engagement, and user feedback mechanism. Non-functional requirements for a smart recycling system with IoT are outlined, covering aspects like reliability, scalability, performance, quality, privacy, interoperability, maintainability, and user experience.
The next summary is the text incorporate an Islamic perspective, highlighting the Maqasid Syariah principles and how they align with environmental preservation through recycling. It emphasizes the Quranic verses promoting stewardship, cleanliness, and the responsibility of Muslims to protect the environment. Next, the concept of wasatiyah is introduced as a balanced approach, encouraging Muslims to find a middle ground between material needs and environmental responsibility. Wasatiyah promotes the avoidance of waste, access, and emphasizes justice and fairness in resource allocation. The text concludes that using recycling bin aligned with Islamic teaching of environmental stewardship and cleanliness. It proposed that adopting a wasatiyah perspective can lead to balanced and collaborative solution to address the challenge of waste disposal while considering practical obstacles and human behavior.
Requirement documentation for application design ensure a clear understanding of the goals and objectives of the application of smart recycling bins. First, the system shall deploy smart recycling bins equipped with IoT sensors to monitor and provide real-time feedback on classification and recognizing type of recycling waste materials. The system should have high ability to ensure continuous monitoring and functionality. It should be able to recover from failures and could be updating and monitoring with minimal downtime. Smart recycling bin must have an implementation as end-to-end encryption for secure data transmission. Data transmitted between the smart recycling bins and users should be encrypted to prevent unauthorized access. The user interface should be intuitive and user-friendly. The system should also provide fast response and deliver notifications to users through mobile apps regarding the usage of recycling bins. Data must be efficiently processed to avoid delays in providing real-time information and serve the users with the best performance. Next, I will explain about the overall architecture. Overall architecture will identify its main component and how they interact. The main structure in smart recycling bins are central processing unit, an Arduino board, and open source electronic platform consists of hardware and software components work as the central processing unit, handling sensors inputs, microcontrollers, communication component, and classification of waste. Sensors including infrared, proximity, and ultrasonic sensors positioned to detect user presence, type of material, and bin field level. The sensors will also sort the waste accordingly to the class of material. There are many sensors that can also be added to the circuit to maximize the functionality of the recycling bins. Microcontroller is also an important architecture in this system. It controls sensors and other components and processes data from them to make decisions. The microcontroller will execute algorithm for waste classification and communicate with the central server. Communication component consists of components that play important role, especially communication with the users, such as cameras, GPS or GMS, Wi-Fi, Bluetooth or cellular connectivity for data transmission, an LED, LCD or other type of display showing real-time recognition and classification of material scan. And lastly, power supply provide the necessary power for the operation of the bins. It can also be battery or a mains power supply.
let's take a look into the subsystems and modules of Smart Recycling Bin. The first module is Sensor Module. This module handles sensor communication, data processing, and triggering specific actions based on the type and amount of waste inserted. The second module is Waste Segregation Module. This module is for sorting waste into different categories like metal, paper, and plastics. And the third one is Data Processing Module. This module processes data regarding waste collection and sorting efficiency. Next is Display Module. It provides information about the waste collected and other relevant data to users through an application or display screen on the bin. Next is Communication Module. This module transmits data between the bin and the central server or cloud using communication components. And lastly is IoT Integration Module. This module improves waste management by linking different components, processing data, facilitating remote operations, and integrating with other systems. Data flow and communication of Smart Recycling Bins. The process begins with sensors and cameras in the bin gather data about the waste. This data is then processed by AI and machine learning technologies, resulting in decisions about waste segregation. Following this, the waste is then mechanically sorted based on the decisions. Subsequently, organic waste is converted into liquid fertilizers, adding value to what would otherwise be discarded. To ensure users stay informed and engaged, a feedback system and application provide real-time remote bin monitoring through data processing. And finally, real-time data about the bin status is displayed, providing users with immediate and useful information about their waste disposal habits.
User interface. We designed the user interface as an interactive touchscreen interface. There are 5 key components of user interface. First, it has clear recycling instructions of visual and textual guidance on accepted items. Second, it has gamified incentive, which is points or reward system with visual representation of environmental impact. Third, real-time field level monitoring. It has graphical representation of bin field levels and notifications for full bins. Fourth, it has educational content that explain recycling benefits and eco-friendly purpose. Lastly, it has feedback mechanism where visible button is added for reporting issues or giving suggestions. Technology stack for Smart Recycling Bins. As for software, we can implement mobile application that has more benefits. It provides user with bin location, field level information, recycling tips, and rewards. As for hardware, we can use sensors for recycling bins. First, proximity sensors that detect when someone approaches the bin. Second, object rejection sensors that identify type of material being deposited like plastic, glass, and material. Next, field level sensors that monitor the bin's field level to optimize collection rates.
Assalamualaikum. My name is NAJATUL binti RASHID, metric number 1211088. I will continue with my part, which is security and performance. First, security. We can enhance security in IoT-enabled smart recycling bins by implement robust encryption protocols to protect data transmit between bins and central servers. Regularly update software to patch vulnerabilities and ensure secure access controls to prevent unauthorized tampering. Second, performance. To enhance waste sorting, we need to optimize sensor accuracy. We use efficient communication protocols to minimize latency, and for real-time processing, we can consider edge computing. Regular maintenance and monitoring can help address performance issues promptly, ensuring smooth operation. Next, we go to design documentation. Objective. Our objective is to create an efficient, secure system for waste management through IoT-enabled smart recycling bins. There are 3 components that we use, which is sensors, microcontrollers, communication module. For security measures, it includes data encryption and access control. Power management, we utilize low-power components to maximize the operational life of the bins. We will also implement a power-saving mode during periods of inactivity. For data storage, we employ cloud storage for efficient and scalable data management. Regularly backup data to prevent loss and facilitate analytics. Waste sorting algorithm, we using machine learning or rule-based system for precise waste categorization. We will also continuously update the algorithm based on collected data for improved accuracy. Next, user interface. We create a user-friendly mobile or web application for remote monitoring and management. We will also provide real-time updates on waste label bin status and analytics. For firmware updates, we will implement over-the-air OTA firmware updates to ensure the latest security patch and feature enhancement. Maintenance, we will enable remote diagnostic to identify potential issues and schedule regular maintenance to address wear and tear, ensuring optimal performance. Compliance, due to local regulation and standard for waste management and IoT devices, we will also obtain necessary certification to ensure the bins meet safety and environmental standards. Next, testing, we conduct extensive testing for sensor accuracy, communication, reliability, and overall system robustness. We will also perform security audits regularly to identify and address vulnerabilities. Last but not least, documentation and training. We provide comprehensive documentation for users and maintenance personnel. We will also conduct training sessions to ensure proper understanding and usage of the smart recycling bins.
Hi, my name is SKJ3192 JAFFAR, matrix number 1211099, and I will be continuing the main point of the application design, which is validate and refine the design. To validate and refine the design of smart recycling bins with Internet of Things technology, conduct usability testing to ensure user-friendly interfaces and efficient sensor integration. Gather feedback from potential users to address any usability concerns and optimize the overall user experience. And lastly, for implementation planning, create a comprehensive timeline outlining key milestones such as sensor integration, software development, and connectivity testing. Coordinate with hardware and software teams to ensure seamless integration of IoT components. Establish protocols for data transmission and storage, considering security measures to protect user information. Additionally, plan for scalability to accommodate future updates and advancement in IoT technology.
Next, I will conclude our presentation today. Smart recycling bins is actually the great way to make the recycling process more easier and efficient. With the connection between the sensors and IoT, we can throw the waste and it will sort the waste by itself. Hence, it will help for more city cleanliness and become a greener future.